Alright, lesson 2.6 is we're going to be simplifying radicals. Our objective is students will simplify radical expressions, and we're going to leave it written in radical form this time. Okay, previously we talked about how to convert them to rational exponents, but this time we just want to work specifically with radicals. Okay, alright, so let's move on. So as always, we're going to start with a little warm up just to kind of see what we remember from previous lessons. Alright, I'll give you guys a second to try on your own. Okay, so now that you guys have tried some on your own, let's take a look at these. So the first one says to simplify 3 to the 4th power to the 6th power, and that's divided by 3 to the 7th power. Well, if I simplify that, I should get 3 to the 17th power, or I should get 129,140,163. Alright, so the next one here, of course, I am dividing, so I need to make sure that I, again, subtract exponents with like bases. Alright, and you can see here you got the z to the 0 power, which, you know, this is going to kind of just make 1 here. So when you simplify that by subtracting those exponents, you should get y to the 3rd power divided by x to the 3rd power. Now you're probably saying, well, how did the x go to the bottom? Because when you subtract 5 minus 8, you're going to get a negative number, meaning that you got to now turn that exponent positive by flipping it, okay? And so that takes the x down to the bottom. Alright, so the next part, it says each of the expressions below can be written in either radical notation or rational exponent notation. And it wants us to rewrite it given the following. So first you see you have the cube root of 27 a to the 5th power, b to the 2nd power. Alright, so the 27 a to the 5th, b to the 2nd is all under the radical. Okay, so if I were to rewrite that, I would group what's inside the radical. And remember, the exponent out here, well, there's none, so it's just 1. And the index number is 3, so that's all of that inside the radical raised to the 1/3 power is how I would write it as an exponent. Okay, and then lastly, I have 9 to the 3rd power, 9 to the 3/2 power, and s to the 6/3 power, and t to the 1/2 power. These are written in exponential form, so if I wanted to convert it to radical form, I can do so as given here. So I should get s squared times the square root of 9 to the 3rd and times t. And you're probably saying, like, how did you get that? So let me show you what I did. So first of all, you can see that both the index number for the 9 and the t are the same. So automatically I know that they're both going to go under the square root. Okay, the index number here is 2. Now, this part, the 3, I know that the exponent on the 9 should be 3, and the exponent on the t should be 1. So when I place them under there, this is what I should get. Now, the s to the 6/3 power, well, you know that a fraction is nothing more than division. So if you come over here and you put 6 divided by 3, you should just get, oh, sorry, I guess I messed something up. So 6 divided by 3, you should just get 2. Okay, and so since when you do this, 6 divided by 3 is actually a whole number, so it's not a fractional exponent anymore. So it's just, it can't go under the radical. So we just put that on the outside of the radical. And when you put things on the outside of the radical, remember they are being multiplied together as displayed here in the expression that they gave us. Okay, so let's move on. So let's see here. Alright, so today we're going to be looking at simplifying radicals, and we all know what a radical is. So first we want to kind of start out, well, what are perfect squares? Okay, so 4 is a perfect square because if you notice that when I multiply double digits of 2, I get 4. Okay, notice how these two things that's being multiplied are basically the same number. Okay, 9 is a perfect square. because I can multiply 3 times 3. 16 is a perfect square. 25 is a perfect square. 36 is a perfect square. 49 is a perfect square. 64 is a perfect square. 81 is a perfect square. 100 is a perfect square. 121 is a perfect square. 144 is a perfect square. 169 is a perfect square. So right now I just gave you just a few perfect squares to kind of work with and to recognize very quickly, but there are multiple numbers of perfect squares that are out there that I'm not accounting for. But if you understand and if you look at this, you'll notice that you see a pattern of what actually make a number a perfect square. And it has to be, in order for it to be a perfect square, it has to be able to be multiplied by 2 of the same digits, okay? So if I multiply 16 and 16, okay, so 16 times 16, doing that over here, I got 256. So therefore 256 would be a perfect square, and that's because when I multiply 16 and 16, I get 256. Okay, so make sure that you kind of jot these perfect squares down, because we're going to be working with these a lot, and so it's going to be really helpful for you to recognize these perfect squares very quickly, so that you won't have a hard time with this. Alright, so let's move on. Alright, so now that we've identified what perfect squares are, now we want to figure out, well, how do we simplify perfect square roots? Okay, so we note yesterday that this is a square root symbol, and we know that the index number here is 2 because there's nothing written there. So therefore, because 4 is a perfect square, when I take the square root of 4, I can simplify the 4 to just taking the square root of 2 times 2, because 2 times 2 will give me 4. So when I take the square root of 4, I just get 2. And it's so you can check that by going to your calculator. And if you notice, you got your square root symbol here on your calculator. To activate that square root symbol, you just have to hit the second key, and then you'll have to hit the x squared key, and you'll have your square root symbol here. So if I want to put 4 in there, look, it gives me a 2. This is how I know it's a perfect square. Okay, so numbers that you put in a calculator that give you like whole numbers back, or they're equivalent to whole numbers, are perfect squares. Alright, so let's look at some more. So if I take the square root of 9, ironically, I know that multiplying the double digits of 3 and 3 gives me 9, but so that means the square root of 9 is just 3. Okay, and you can double check that in your calculator. Go second x squared, and I put 9 in there, and I get 3. So instead of writing the square root of 9, I can just write 3. Alright, so the square root of 16 can be rewritten as 4 times 4, or the square root of 4 times 4. So therefore, quite naturally, if you follow the pattern that you see here, the square root of 16 should just be 4. Okay? Okay, now, when taking the square root, we are taking the square root of perfect square numbers. This is what happens when we take the square root of perfect square numbers. But what happens if the number is not a perfect square? We still have to know how to deal with that, and we still have to know how to handle that. So let's look at some examples. So how do we simplify square roots when we do not have perfect square numbers? Well, that's a very good question. Let's take a look though. So let's start off with an example. So first of all, I want you guys to notice that I have the square root of 50. And if I go over here and I put the square root of 50 in my calculator, I want you guys to see what's going to happen. You should get a decimal number, okay? And you will recognize later that this makes an irrational number. We'll talk about that later. Okay, but the square root of 50 is an irrational number. So you have this decimal number that's here. It's not pretty like the whole numbers when I was taking the square root of perfect squares. It's not very pretty. Okay, and so how do we simplify things, or how do we simplify this when it's not a perfect square? So this is what we're going to do. Our job is to find all the perfect square factors that are in 50. Okay, and let me show you what I'm talking about. So for an example, I want to take the square root of 50. So when I take the square root of 50, I know that I can rewrite 50 as the square root of 25 times 2. Now these are factors of 50 because they are things that I'm multiplying together. Alright, now I want to show you something in your calculator that will also help you, because notice that I could choose any number that I want to that will give me 50, but I specifically chose 25 and 2. I chose 25 and 2 because I know that 25 is a perfect square. Okay, and that's kind of what I want to do. I want to try to find these perfect squares. So let me show you something in your calculator, just in case if you're not really familiar with factors of numbers. So in my calculator, let's say I wanted to, let's back up and say I wanted to find the factors of 50. So I'm going to go to y equals, okay, and I'm going to clear this. So I'm going to go 50 and I'm going to divide it by x, okay? And like we've done this before, okay? I hit second graph, and now I have all my factors of 50. And as you can see, I can stroll up. I can use any of these numbers that I want to. They just have to be whole numbers. So I could use 10 and 5 if I wanted to. I could use, let's see, what else? 1 and 50, but that's not going to help me out. But instead, I chose to use 2 and 25, and the reason I chose to use 2 and 25 is because I recognize that 25 is a perfect square, so it's going to make my life a lot easier. Alright, so when we go here, we see that we chose 25 and 2. So I write those still under the square root because we haven't taken the square root yet. Alright, so now I can break this down a little bit more because I know that 25 is a perfect square, and so instead of writing 25, I just wrote 5 times 5. Well, that 2 still stays there because these numbers have to always, at all times, when you multiply them together, they have to be equivalent to whatever is under the radical, and in this case is 50. Okay, so now I have these numbers here. And if you notice here, if you don't take a look at the 2, and if you go back to the previous thing when we were talking about perfect squares, you'll see where I have 2 5s. Okay, taking the square root of this allows me to now take 1 5 out because I know that 25 is a perfect square. So guess what? Because I have 2 5s here, I can pull one of those 5s out. And so when I pull the 5 out, because of the square root of 25 is just 5, that comes outside of the radical, so it's no longer in there. And the 2, well, the 2 is not a perfect square, so it has to stay underneath the radical. So then I'm left with 5 times the square root of 2. Okay? And just for giggles, because all we did was simplify this, we didn't change the value of it. So if I come back over here to my calculator, I can check it. So I'm going to put the square root of 50 in my calculator, and I'm going to hit enter. There's your decimal number. Then I'm going to hit 5 times the square root of, okay, 5 times the square root of 2. And I'm going to hit enter. Notice how you get the same value because they are the same thing. They're equivalent to each other. The only difference is that one is more simplified than the other. That's it. Alright, so let's look at some more examples. Alright, so now we got 300 here. So 300, I have to find factors of 300. When I do that, I want to try to find perfect squares. So if I'm not very good with factors, I'm just going to go to y equals, put 300, divide that by x, and then I'm going to go to second table or second graph, and I'm looking for numbers that's going to give me a perfect square. Okay, I know what perfect squares are. There is one. I got 12 and 25. I could use that. I'm going to keep going and just see. Let's see. Oh, wow. Look, 3 and 100. Okay, so I'm probably going to use 3 and 100 because I know 100 is a perfect square. But you guys are more than welcome to use any of these numbers. Okay, so if I use 3 and 100, I get the square root of 3 times 100. So quite naturally, I know that I can rewrite this like this because 100 is a perfect square. So guess what? I can already simplify this because I have two of these numbers that are the same. So therefore, this is just going to simplify, bringing one of these 10s out because I have two 10s that are under the radical. So bringing one of the 10s out, and that is not right. Let me pause that here. Okay, so I always have to do my normal mess up kind of thing, but okay, so I'm back on track now. So again, I messed up. It should actually be 10 times the square root of 3 because I have two 10s here. So that means I can pull one of the 10s out. Okay, and the 3 doesn't have anything to map with it to pull out, so it stays under. Let's look at another example. Wow, a bigger number here. It doesn't matter. It doesn't change anything. We just go to y equals, and we try to find factors in our calculator. So we're going to do 3675. And we divide that by x like we've always done, and then we hit second and graph, and now we can find some factors. And of course, when I'm looking for factors, I'm trying to find perfect square numbers that I recognize. Okay, and I'm gonna go down as far as I need to. It doesn't matter. I'm just gonna stroll. Oh, I see something right here. So I saw 49. And I know 49 is a perfect square. So I'm going to use 49 and 75. So I now can, instead of writing 3,675 or the square root of 3,675, I now can write the square root of 75 times the square root of 49. Times 49. Okay, so all of this is under the square root, but I recognize that 49 is a perfect square, so I know automatically that I can rewrite 49 as 7 times 7. Okay, now the 3 times the 25, well, those are just factors of 75. So if I needed to, I go back here and I plug in 75 divided by x, and I just find factors of 75. And so as you can see, quite naturally, I chose, because I'm always going to be looking for perfect squares. Okay, well, every time I recognize them, that's why it's important that you guys learn those numbers. Okay, all right, so 3 and 25, those are going to be, that's where that came from. But more importantly, when you multiply all of these numbers together, they should always equal what you started with. In this case, it should be 3,675. Wow. Okay, so now I see that 5 is now a perfect square. So I can rewrite that. I can rewrite that as 3 times 5 times 5 times 7 times 7, and it doesn't change anything. It doesn't change the value. So now I have basically like two perfect squares that I was able to find inside this number. So now I see that I can pull out a 5 because I have two 5s here, and I can also pull out a 7. Well, this 3 has to stay in there, so I'm left with 5 times 7. So when I pull a number out, notice that I'm multiplying them together. You're not adding them together when you pull them out of the radical. You need to remember that you're multiplying them together. Okay, so this basically says 5 times 7 times the square root of 3. Well, outside you can simplify that to kind of make it neater, to clean it up. So you just multiply those numbers together. 5 times 7 gives you 35 times the square root of 3. And like always, if you come to your calculator, you can just double check it just to make sure it's correct. So I will start with the square root of 3,675, and of course that gives me that, and then I can do 35 square roots of 3, and I should get the same thing, in which I do, so I know I'm not changing the value of anything. Alright, so let's keep it moving. Alright, so we're going to look at some more examples, but let's throw some variables in there because they have basically the same concept as well. So we have x squared. Okay, we're taking the square root of x squared. Now, I know I can write x squared as x times x, or the square root of x times x, because it's the same thing. I'm following the same pattern. I'm not changing anything up, because if I multiply these back together, I should get x squared. Okay, so I see that, oh, I got an x that's under there. So quite naturally, to simplify this would just equal x. Okay, I didn't have to do anything in a calculator because right now I didn't have any numbers to kind of play with. All right, let's take a look at another example. What if I have x to the third power? Well, that's the same thing as just writing the square root of x times x times x. And you see that, well, I have 3 x's this time, but I need at least 2 x's in order to pull one of the x's out. So I look here and I say, okay, these 2 x's make a pair, but this one doesn't have a pair. So what do you think is going to happen with that x? It's going to stay under the radical. So this, you can pull one x out, and then that other x that doesn't have a pair has to stay underneath the radical. So therefore you have x times the square root of x. Okay? Are you guys noticing like a little pattern here? Hopefully you are. If you're pulling numbers out in pairs, okay, it's almost like dividing by 2. So if I divide, let's say, because this index number is 2, 2 divided by 2 is 1, so that just lets me know that I can pull out 1x. Well, over here, 3 divided by 2, because 2 is our index number still, it's not going to give me a whole number. So let me show you what I mean. So 3 divided by 2, it's like 1.5. So that just tells me that I can pull out 1x, okay? But that's it. I can only pull out 1x, so 1x should be out there because of these pairs right here. And if you'll notice that you'll have a remainder of 1, so that remainder means that 1 have to stay in there. Hopefully you guys understood that. If not, hopefully you guys can see pictorially what I'm talking about and where I'm trying to get at. Okay, so let's move on. Let's take a look at one more example. Now this time we're looking at the square root of 18x squared. Now they're both under the radical. Well, we know how to take the square root of numbers, and we kind of know how to take the square root of variables. But so now we need to put them together. We can't throw something that we've already talked about away. All right, so let's put them together. So I have 18 x squared. So now I can rewrite this whole thing. So I'm going to go here and look for factors of 18. And if I look for factors of 18, you guys should see that my factors should be 2 times 9. And of course, quite naturally, this is x times x. All right. And so now I say, okay, well, I know I have a pair of x's, so I know at least 1 x is going to come out. Oh, and I also have a perfect square. Okay, so this is a little bit easier now. All right, so I see that, let's back up a little bit. I see that I have these 2 3's and these 2 x's, so these 2 3's means I can pull 1 3 out, these two x's means I can pull one x out. Can't do anything quite with the 2, so the 2 has to stay under the radical. So that will leave me with 3x, right? Because I can pull out a 3 and I can pull out an x times the square root of 2 because I couldn't pull that out. And this should be the most simplified. Okay, so now that you guys have kind of went through and understand how to simplify radicals using variables and numbers and things like that, I want you guys to try some on your own, and we'll come back tomorrow and take a look at it.